viewed, and your data might be misinterpreted because you might have huge spikes that really aren't really huge in your information. Another issue that these graphs have, that they can become cluttered because you have more than 3 data that you want to represent on one graph. So when you do that, it becomes really confusing on where all the dots are and where they cross and where they go up and down. And what we have here is one that I found on the poster that I cut and paste. Some of the strengths of this one is it's clearly labeled. You can tell they want to tell us about the cycle length and the state length per second. So the information is clearly labeled where you can tell what how much they represented across both axes. The rate of change is representative to each other, so it won't be skewed. And there's no more than 3 different informations on this graph. Now, some of the downsides of this graph that I found was it's really cluttered because there's a lot of information that they're trying to put on dots on this. So it's kind of hard to tell like where this dot is and where it lines up for the exact amount. The colors aren't real distinctive because the purple and the blue kind of mesh together. So it's kind of hard to tell between those two. And they don't connect them with lines. They actually do a slope, overall slope, to tell you where the graph is leading. So it's a little harder to tell where it goes up and down.
And this is our references where we found most of our information outside the posters. Bar chart information we retrieved from the Wikipedia, and the line chart we found at the one of the posters which Michael explained. And the other ones that we use extensively is our course book. And this concludes our presentation. Thank you.
Any questions from anybody?
What's a board?
What?
Was that Matthias again?
I use the simplest definition. You're so dumb that I cannot do anything.
I like
Face of the
it.
class.
Oh, okay, see?
Phase 3.
I was just seeing if you're paying attention there. You're good, you're
Doesn't
good.
seem to be working. Broken.
Good job.
Touched it.
He touched it. And he breaks stuff when he goes.
Don't tell me you broke it, too.
I didn't do anything.
Okay, wait, are you ready with that?
Besides the G20
Ahmed?
Yeah.
Okay, so we're the red group, and I'm Kias. This is Nick, that's Peter, and this is Christian. And we will be talking to you today about information tables, decision tables, and cross-tabulation. And information tables. Nick will talk to you about information tables.
All right. We've all seen information tables before. They're in most of the textbooks we use. But basically, information tables consist of a series of rows and columns. They're really good for organizing data, particularly numerical data. They're good for comparing and contrasting different groups of data. It's really valuable in getting a quick overall look of the data you're looking at. Now, these are the parts of an information table. You usually have a title up top. This one doesn't actually have the grid in there, but you can imagine, like in Excel, there's a series of rows and columns here. Let's see. Your column labels are listing the data that is being compared here. And as you can see, this is a numerical example. One of the neat things about information tables is they're also can be used to present non-numerical data that might be difficult to find in text. Like this next example. This is alphanumeric, or not alphanumeric, phonetic alphabet and Morse code. If I tried to write that in a paragraph, A period, dot, 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 period, it would be very confusing, but it's pretty easily seen in the information table there. Next, we have Christian, who's going to talk to you about cross-tabulation.
Cross-tabulation shows results of 2 or more sets of shows the results of two or more sets of data alongside each other for comparison of the two, basically. This allows the person to showing the data to show trends to the data based on however they care to manage it. And it's excellent if you wanted to display, compare different sets of information, but you get the same results? Sorry, do you get the same results?
This is right here.
Okay. You want to compare and contrast different sets of information. Like in this case here, you can't really see too well, but it's taking like somebody's age based in, and then it's showing what looks like, how they run different purchases, what they're most likely to purchase and whatever. And then below it, it shows different ages, so you can source various data trends on whether they're gonna buy shoes or computers based on their age. And it's a good way of tabulating data that way, because it's easy, you can look at it and say, okay, somebody's 20, how likely are they to buy whatever this? And you know, you compare it if they're 25 or 50 or whatever. And sorry. And one issue that comes up with a cross tabulation like this is